Today we are going to discuss about probability. This is very important, not only in 9th class, it is also helpful for 10th class. Not only in 10th class, in intermediate second year also we have the probability. That's the reason we have to learn all basics of probability here. Let us take an example. Why we have to learn probability? So in general you are playing with die in some games. See here we have one die with me. Everybody knows it has 6 spaces. In each space we have a number or a dot here. So if you take one dot here, one dot, exactly the opposite you have 6 dots. That means in one place is considered as 6, another place is considered as 1. Similarly, we have 6 spaces. We are writing 6 numbers. In each space we have one dot, means here I would like to consider 1 and 2, 3, 4, 5 and 6. So in one place we have one dot, in second 2 dots and 3, and the next one is 4 like this, and 5 like this, and 6 like this. Okay? Anyhow, when a die is thrown up and fell down, it shows the upper face. We consider only upper face. What is the appearance? Maybe 1, maybe 2, maybe 3. Depends upon the event. I told you clearly, when thrown up, it is at this position at one certain time. When falling down, it appears something, maybe 1, maybe 2, maybe 3, maybe 4, and so on up to 6. So there is a chance for 6. There is a chance for 1. At the same time, there is a chance for 2 and so on. So when it is coming down, no doubt at all, it shows any one of it. That is here you call chance. This is one chance. 1 you have one chance. At the same 2 have same chance. And 3 also have same chance. And 4 and 5 and 6 also have same chances or equal chances. So this is an experiment. We can say that a die consisting of 6 numbers. 6 numbers have equally like chances. Isn't it or not? Suppose these are the total chances when it is here. When fell down, it shows only one chance. It will show only 1. Maybe 1, maybe 2, maybe 3, maybe 4, maybe 5, maybe 6. That is one chance we consider. Suppose 6 appears in the top. 6 appear in the top. 6 is a one chance. You take only one chance. This is a one chance. But how many chances we have? 6 chances. So here one chance divided with total number of chances. These are the possible outcomes. This is favorable outcome. Suppose I expect 3. I have only one chance. When a die is thrown, top appear, maybe 3, may not be. But I have a chance. The chance by total how many chances are there? 6 chances. 6 out of we have only one chance. That is 1 by 6. Here you consider as the probability of 3. So 1 by 6, somebody is writing 3 by 6. No, 3 appears getting only one chance. The chance you have to write, not 3. 3 appears, no doubt at all. If you write 3, it gives 3 favorable chances. Don't write like that. Here we have to write only 1. Totally we have 6 chances. Out of we are taking one chance when die is thrown up. Isn't it or not? So here I would like to explain one more thing. 3 have only one chance. 1, 2, 4, 5 and 6 are other chances. Those are called 5 by 6. This is the probability of remaining chances. Isn't it or not? So this is 5 by 6 and 1 by 6. You just consider when 1 divided with 6 or 5 divided with 6, it gives the values lies between 0 and 1. These two values lies between
0 and 1.
0 and
1.
1. So here very important point. 1 is a favorable outcome and 6 is a total number of outcomes. The ratio of favorable outcomes by the ratio of favorable outcomes by total outcomes is nothing but probability. So here this is an event. In a random experiment, this is an event. In event, I expect 3. This is called P of 3. The probability of 3 when a die is thrown up once. Do you understand my point? So the ratio of favorable outcomes by total number of outcomes, here written P of E is equals to favorable outcomes by total number of outcomes. This is an event. In a random experiment, every outcome is an event, or a favorable outcome is an event. Is it clear or not? So event is a term which is used in probability. An event is nothing but in an experiment every outcome is an event. In a random experiment every outcome is an event. So here my event is what? P of 3. P of 3 is an event. The favorable outcomes here 1. Don't write 3. 3 is my chance. One chance. One chance by total how many chances are there?
6.
1 is called favorable outcome. Outcome here we write down. The chances here you have to write. 3 represents the favorable outcome. In this die we have only one chance. That's the reason 1 by 6. Suppose when die is thrown up, I would like to expect 2 or 3. When die is thrown, I expect 2 or 3. That is you write P of 2 comma 3. How many chances we have? 2 chances. Write down. The 2 here write down. Don't write 2 plus 3 or 2 into 3. These are the 2 chances for me when die is thrown up. 2 chances. By total chances how many are there? 6. This is also one event. When die is thrown up in a random experiment, what favorable outcome you are expecting? That is an event for you. Here 2 and 3 means you don't expect 2 events. This is a single event, but I have 2 chances. Those are 2 and 3 comes up. If 2 or 3, if 2 is comes up, I will win. If 3 is comes up, I will win. In rest of 1, 4, 5, 6. This is the loser. When 2 or 3 comes up, I will win. Otherwise, second person will success. Right? So, by observing these 2 cases, here I have only 2 chances. But the second person have 1, 2, 3, 4. 1, 2, 3, 4 chances. That is how much? 4 total by 6. So by observing these 2, my success rate is less than second person. Isn't it or not? Suppose this is the first person and he is the second person. He expect 2 comma 3 comes up when die is thrown up. That means I have only 2 chances. But the second person have 4 chances. 4 by 6. This is we have to write P of 1. The next one is 4. Next one is 5 and 6. The probability of getting 1, 4, 5 or 6 is equals to 4 by 6. These are the numbers what we are expecting. These are called favorable outcomes. Total chances here we called total outcomes. The favorable outcomes by total outcomes is nothing but probability we define with the help of these conditions. Do you understand my point? Favorable outcomes by total number of outcomes. The probability is nothing but the ratio of favorable outcomes by total number of outcomes. That means you are doing some division here. You are applying some calculations. 4 by 6 gives something and 2 by 6 gives something. Those are lies between again 0 and 1 only. Probability lies between 0 and 1. That's the reason in probability one statement is given in our textbook. Title inside the one statement here. Probability theory is nothing but common sense reduced into calculus. This is the common sense. You reduce into calculation. That's all. But we are doing some calculations. The favorable outcomes by total number of outcomes is nothing but probability. Here some terms are certainly you are using in probability. That is the first one, certain. Certain means what? Suppose I would like to take a bag contains, this is my bag, contains some red balls. I would like to take 4 red balls. I would like to 5 red balls. So this bag contains 4 red balls. What is the probability of red ball here? 5 chances we have. Total how many chances inside? 5. So 5 favorable outcomes. And total number of outcomes also 5. That is equals to 1. This is called certainty. This is also called sure event. This is also called sure event. Very simple. When you mix all red balls inside the bag, pick the ball without looking to the bag, we get only red. In any event, that's the reason this is a sure event. Suppose here I gave some blue balls here and blue balls here. See here, I would like to get a ball from this bag that is should be a black. Is it possible? Is it possible? Here blue balls are there. Suppose I would like to take a ball from this bag that is must be a yellow ball. Is it possible?
Impossible.
No, that is called impossible event. The impossible event means there is no chance. 0 by total 1, 2, 3, 4, 5, 7 is nothing but 0. So impossible event, the values must be 0. 0 is a impossible event, 1 is a sure event, and probability lies between 0 and 1. So certainty means sure event only. Do you understand my point? Here, more likely and equally likely, less likely. These are very, very important. So when die is thrown up, like 1 will get 1 chance. At the same time, 2 also have 1 chance. If you take 3 also only 1 chance. The 6 numbers in our die have equally like chances. Suppose if you take this bag. In bag 5 red balls and 2 blue balls. Suppose I would like to take red ball. It more likely, more chances to get red ball. That is called more likely. Suppose if you consider blue balls, less likely. The probability more for red and less for blue balls. These are called less likely and more likely. And equally likely means you can take a die or a coin. When coin is thrown up, maybe toss, maybe head, maybe tail. So they have both have equal sizes when coin here. When release the coin, it may be red, it may be head, it may be tails. Both have equal chances. That is called equally likely. So when coming to the probability, very important point here I would like to discuss. One, two, three, four, five. Oh. Here I would like to write 6. 1, 2, 3, 4, 5, 6. These are the numbers on the die. So I already told every number in my die have equally like chances. The probability of 1 we have to take here P of 1. Is it eternal? This value you consider like 1 by 6. 1 by 6 is a probability of 1. Similarly, P of 2. 1 by 6 only. Why? 2 have only 1 chance. Similarly, 3 have 1 chance. The P of 3 is nothing but 1 by 6. P of 4 is nothing but 1 by 6.
P of 5.
P of 5 is nothing but 1 by 6. P of 6 is nothing but
1 by 6.
These are all probabilities of an event. When we done an experiment, these are all probabilities. Very important points. Sum of all probabilities of an event. An experiment, not even in experiment, total number of probabilities P of 1, P of 2, P of 3, P of 4, P of 5, P of 6 is always equals to 1. Why? Because 1 by 6 plus 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 1 by 6 is equals to 6 is a common denominator. We can take 1. So you add all 1 plus 1 plus 1 plus 6. That is equals to 1. Suppose I will do an experiment. Like this. Suppose one die is thrown. It's an experiment. I expect 2, 3, 4. I am expecting 2, 3, 4. How many chances I have? 3 chances. By total number of chances?
6 chances.
This is the probability of 2, 3, 4. 2, 3, 4. Here 2, 3, 4 are powerful chances for me. That's the reason 3 by 6. Rest are 1 by 6. Probability of 1, 5, 6. This is 3 by 6 only, because suppose I have 3 chances. Rest chance will go to the second person. Is it or not?
Yes, sir.
When we are doing some game, is it or not? Sum of 2 events, 3 by 6 plus 3 by 6 again 6 by 6, that is equal to 1. In this event, sum of probabilities must be equals to what? 1 only. In an event, sum of probabilities always equals to 1. Probability lies between
0 and 1.
Okay. This is calculation or not?
Yes, sir.
This is the common sense calculated or not? That's the reason. The probability theory is nothing but the common sense reduced into calculation. Who told this one? Simon Laplace is a scientist. Suppose two coins thrown up. Two coins are thrown up. Two coins thrown up at a time. Here you have two coins. Every coin have head and tail. Head and tail. Before coming down, by showing faces up, how many possible chances are there? We'll see. Two chances. Suppose this is head. It may be head. That means what? Here I would like to head. H stands for head. When thrown out, when coming down and shows both maybe head. Maybe it is not happened. Here only they are coming down. Maybe head and maybe tail. This is head. This is tail and this is head. Both are tails. Both are head. One head and other one tail. Isn't it possible? Do you understand my idea?
Yes, sir.
For falling down, it have these many chances. This is you taken as one unit. This is one chance. Don't write 1 plus 1, 2 chances. This is a unit. And this is 1 unit. One more chance. This is a 1 unit. This is one more chance. Total how many chances are there?
4 chances.
4 chances. Do you understand me? Don't calculate 1, 2, 3, 4, 5, 6, 7, 8. No. H and H. One chance is when 2 coins thrown up, we'll get 4 chances. In which I am asking any one of it head. When thrown 2 coins at a time, I expect any one of it head. Then I will win. Otherwise, I lose the game. Isn't it done? That means how many chances I have?
2.
I am asking any one of it head. I told you any one of it head. I told you before? No. One head and one tail. I am expecting,
One head and one tail.
or you can say either head or tail. Head or tail, simple. Suppose 2 coins thrown up, I am expecting head or tail. Head or tail means these 2 chances. Head or tail I am expecting. Both are head, I lose the game. Both are tails, I lose the game. But I am expecting one head and one tail. An event. Totally 2 events, 2 chances I have here. 2 by total number of chances.
4 chances.
4. Somebody is writing 8. No. This is 1 unit and this is 1 unit and this is 1 unit and this is 1 unit. Do you understand my point? I am expecting one head or tail. Then we get 2 chances. First one head and second one tail. And first one is tail and second one is head. That's the reason we have 2 chances. 2 by total chances 4. That is equals to 1 by 2. 1 by 2 is nothing but how much, tell me? 0.5. I told you clearly the probability lies between 0 and 1. Is it there or not?
Yes, sir.
If it is directly 1, it is a sure event. If it is directly 0, it is a impossible event. This is also called 1 is also called certainty. So, okay, leave it. Suppose I lose the game when you not appear H, T or T or H. Both are H or both are T, someone is gained, right? Second second person will win the game. That's the reason. At the same time, he have same chances. That means 2 by 4. Total 4 chances. He also have 2 chances. 2 by 4 is nothing but what again? 1 by 2 is nothing but 0.5. 0 point plus 0.5, how much? Sum of probabilities. This is one probability, this is other probability. In an event, 0.5 plus 0.5 is nothing but what? 1 only. 1 by 2 plus 1 by 2 is nothing but what? 1 only. That means sum of probabilities in a particular event is always equals to 1. Is it clear or?
Yes, sir.
That's the reason Simon Laplace says that the probability is nothing but common sense reducing calculation. Can I tell one more problem?
Yes, sir.
Suppose I have 2 dice. Suppose I have 2 dice. When thrown up, when I throw the 2 dice at a time, 2 dice at a time, then how many possible outcomes will come? We'll see with this example. Okay? 1, 2, 3, 4, 5 and 6. Here 1, 2, 3, 4, 5 and 6. See here, very very important. When we had thrown 2 dice at a time, maybe both tops appears 1 comma 1 or not. Maybe 1 comma 1 or 1 comma 2 or 1 comma 3 or 1 comma 4 or 1 comma 5 or 1 comma 6. Similarly, maybe here one die shows 2, other die shows 1. That means 2 comma 2, 2 comma 3 and so on. Total how many chances you know? Here 6 comma 6 also comes out. Total 6 are 36 possible outcomes will come. Suppose you are expecting 2 comma 2. We have only 1 chance. 2 comma 2 is a unit, 1 chance. 1 chance by 36. Very less like possible for me when I doing a game in front of the second person. And die is thrown, I am expecting only 2 comma 2. I have less chances compared to the
Second person.
who conduct the game. That's the reason we are using less likely, equally likely,
More likely.
Now understand? These are the terms very very important. To understand the probability, first you should know probability is nothing but the favorable outcomes by total number of outcomes, or you can say probability is the ratio between favorable outcomes by total number of. Probability always lies between 0 and 1. Understand my point? Sum of all probabilities is always equals to. Sum of all probabilities is always equals to 1. Suppose this is 1 by 36. This is my chance. Remaining chances how many are there? 35 chances. The 35 by 36. By adding these two in a one event, by adding these two how much again? 36 by that is nothing but 1. Do you understand my point? Suppose this is the P of E. This is P of E dash. This is P of E. This is nothing but P of E dash. E complement. P of E, probability of event. Probability of not an event. Probability of not an event. Not E anukunta. Probability of not E. This is the probability of event. This is the probability of not event. That is always equals to 1. Suppose I told you somebody, ask you one person, the probability of an event the probability of an event P of E is equals to 0.01. What is the value of P of E complement or not E? I need to find this one. Very simple. This plus this is equal to how much? 1. I need this one. P of E complement. That is equals to 1 minus P of E. Can I write like this or not?
Yes.
Yes. That is equals to 1 minus 0.01 is nothing but 0.99. 0.99 plus 1 how much? 0.01 is nothing but how much? 1 only. By adding these two again you get 1 only. Is it clear? They will ask some questions like this.